shark bite today, what questions do we want to see, do go over, have questions about? See a lot of 1s and 2s, and then it's a toss-up between 3, 4, and 5. So everyone put up one of those numbers. Threes, 1, and down. So 1, 2, and 3 will be those. We'll simplify number 1 by hand, and then I'll show you that in the calculator in Desmos so you can practice that. So here we are dividing like basis, so we're going to subtract our exponents and actually divide the 2 over 6. So it'll be 1/3. Subtracting our exponents, we have x to the negative 4, y to the 5th, z to the 6th. The x to the negative 4 is going to get brought down. The y and the z are going to stay in the numerator. So y to the 5th, z to the 6th, over 3x to the 4th should be your final answer. And then in Desmos, I would have to capitalize x and y. Add in all your sliders, change these to something, I would say leave them positive, but just something different. And then when I put in my final answer, which was y to the 5th, I put y to the 5th. Those numbers should be the same. And mine's really big because I chose bigger numbers, but if you did like not so big numbers, you get smaller. But they're the same, that's all that matters. So you can use Desmos to check yourself, but not to solve this initially. You have to know your exponent rules in order to do this properly. Questions on that one? Okay, number 2. Write the equation of a line that's parallel to the given equation but goes to the point -1, 5. So I'm going to go ahead and type that in. The order pair and the equation given. And if it's parallel, I need something with the same slope, so I'm going to type in y equals mx plus b. Add in sliders, add in all sliders. Make the slope the same, so 2. and then move my b until it goes through that point, which would be at 7. So the equation would be y equals 2x plus 7. If you use Desmos, make sure you use Desmos. And then for number 3, we have to solve this by hand. We're trying to get x by itself, so we have to get rid of a by adding it to the other side. And then divide everything by 5. So x equals b plus a over 5 would be b. Yes. Yes, sorry. Because we're not subtracting, we're adding. I just looked briefly at that. Questions? Okay. Make sure your name is on your check by answer sheet before you pass it up. And okay. For 15, you have to put in the signs that would make this true. The first one was greater than or equal to. The second one was greater than. In 16, so if you were doing this on the computer or on the app, it would be a drop-down menu, but can't do that, on the paper. So the first one would be down, and the second one would be steeper. And then go on to the next page. $17 was similar. The first one was 1/2. The second one was 2 more than. And for 18, you should have had any 2 of these points. You should not have had a line through it, just 2 points plotted. There will be some that may have you draw the line, but what will happen is you'll plot 2 points and the line will form on its own. But if it just wants you to plot 2 points, don't do more than that. Then go on to the next page. 19 is actually something we're going to talk about today. But if you knew what to look for domain and range, the range would be everything greater than or equal to 3. If you put that into Desmos. For the zeros, if you put these into Desmos or the calculator, the ones that cross the x-axis only once was the g of x and the j of x equations or functions. And then 21, the functions that had an x-intercept of 3 were the h of x and the k of x. And then the problems that are due next Tuesday would be the rest of the packet, 22 through 28. Are there any questions we just went through that we want to see by hand or in Desmos? Once you have all those down, go ahead and look at the notes for today. Some of this is going to be familiar. Some of it's going to be reviews. Because we did talk about domain and range, but specifically for quadratics and exponential functions and a little bit with our relations. Our domain is what? What does that represent? The x's. Or the x values. What about the range. So it's really important that we keep that straight in our minds so we don't mix them up. When we talk about domain and range, we're going to be talking about two different types of graphs. One being discrete. That's a graph that has like random points. So a lot of the relations we were talking about were discrete functions. And then continuous, which are graphs with a line or a smooth curve. So all of your linear functions, your quadratic functions, your exponential functions, those were all continuous functions. Yes. This will also have some previous review in this, talking about x and y-intercepts. And just the other words for x-intercepts. That is also known as zero, because if you substitute it into the function, it makes the equation equal to zero, or a solution, or a group, because it makes the function true. So first we're going to determine what type of graph we're given, a discrete or continuous. Which one would this be? Discrete. Because it's a bunch of random points all over the graph. Then when we write our domain, just like with our relations, we're going to list out our domain left to right with no repeats. So the furthest point to the left would be -4, and then keep going. What's the next point? -2. -2, keep going. It doesn't have to be relative, just any one. -1, and then 1, and then 3. So you would list those out, least to greatest, left to right. Range, you're going to do the same thing, but lowest to highest. So the lowest value would be -4. And then we're going to keep going up. What would the next one be? 2. You would only write that once, and then the next one. 3, and the next one. 4. So you would list out your domain and range in curly brackets. This is the set of numbers. And then, is this a function? Yes. It passes the vertical line test. There are no repeating x's. Questions on how we determine domain and range from a discrete function? And one more discrete before we move on to continuous. So this one again is discrete. So we're going to list out our domain from least to greatest, left to right. What would that start at? -6. Keep going. -3, 2, and 4. And then for our range, lowest to highest, what would that be? -8. Keep going. -4, 3, 1. Is this one a function?
No.
No, because it would not pass the vertical line test. This one has the same x going to 2 different y values. Any any questions on how we write domain and range for discrete functions? Okay. Now we're going to move on to continuous. I know this is continuous because I could start at one point and not pick up my pen or marker, pencil, whatever. But when we write domain and range for this, it's a little different. We're still going to start off with curly brackets. And if you want, you might want to draw in like lines where the furthest point to the left and the furthest point to the right are. Because those will be the only two numbers you need. And you're going to write this like this. It's always going to start off x such that with a vertical line. Whatever the furthest point to the left is, what would that be? -5. Then you're either going to put less than or equal to, depending on the type of dot you have. These are closed, so less than or equal to. X goes in the middle, less than or equal to again, and then the furthest point to the right, which is 6. And curly brackets. So anytime you have a starting and end point, it's always going to look like this. You need both less than or equal to's with x in the middle, furthest point to the left, furthest point to the right. This is saying everything in between -5 and 6, all the negatives, positives, 0, fractions, decimals, everything in between there is part of your domain. But we wouldn't want to list out every single number because that would be a lot. Range, we're going to do the same thing. Again, if you want to put lines where your lowest and highest are, you do that. Only lowest and highest if there are other points, ignore those. They'll start off similarly, curly brackets, but this is range, so y, such that, the vertical line. What's your lowest value? -3 is less than or equal to y, which is less than or equal to, what's our highest? 4. So we would write our domain in range like this. Do you have any questions, confusions on how we write this notation so far? If we were doing this in interval notation, these would both be square brackets. And you would just put from -5 to 6 or from -3 to 4. You will most likely see set builder notation more than interval notation, but be able to switch back and forth. Then just for review, what are the x-intercepts here? -4 and 2. So we're going to write those as ordered pairs. -4, 0, and 2, 0. What about the y-intercept? If yours falls exactly on -1, go for that. Mine is like in the middle. So I'm going to put mine like at -1.5. Is this a function? Yes. Any questions, confusions on anything we just said? We're going to try the next one together, and then you guys are going to practice one. So again, if you need to put in lines where the furthest left, furthest right, lowest and highest are, you can do that. Domain, we're going to start off the same way. Curly brackets, x, vertical line. What's your furthest point to the left? -4 is less than or equal to x, which is less than or equal to 6. I think it's actually at 5. Okay, then how would we write the range? Start at the beginning. curly brackets y such that -6 is less than or equal to x. So this one would be y less than or equal to 6. So your range will always have 2 y's, your domain will always have 2 x's. What is the x-intercept here? It may be at a decimal, you can make up one. Sure. 0.50, and then the y-intercept. Is that a whole number? You can say that. If it's at a decimal, you can make up one. So if yours falls out 1, go for that. Mine is like in the middle. I'm going to say -0.5. Is this one a function? Yes. The rectangle on the next page, once you finish this, I want you to try that, and I'll give you a couple minutes to do that, and then we'll come back and talk about it. What would the domain of this one be? What's the rest of that? Which is less than or equal to 6. That would be at 4. I'd already written the first part, but make sure you're including the curly brackets x such that the vertical line. What would the range be? So they're very similar, except their last point is 1 off. They would both be in square brackets if you're writing it in integral notation. What are the x-intercepts? 4 is one of them, and -5. And the y-intercepts? -6. Is this a function? No, it does not pass the vertical line test basically everywhere. Do you have any questions on how we find domain and range of these types of continuous functions? So anytime you have a starting and ending point for domain or range, you're going to write it like this. Now we're going to look at some continuous functions that have arrows instead of endpoints and see what happens there. So in example 3, this is a quadratic. We've done domain and range of quadratics, but similar. For your domain, you have to imagine that this keeps going off the graph, down and left, slowly, further and further. And then it keeps doing the same thing, keeps going off the graph, down and right, slowly, slowly, forever and ever. So where would that start? And where would that end? So the domain starts off the same, curly bracket x such that. Then you're going to write x, this weird e, and like a double r. And that means all real numbers. It keeps going from negative infinity to positive infinity with everything in between. So anytime it goes in both directions, that's what you're going to write. Now for the range, what's the lowest value? If this keeps going down. Negative infinity. And what's the highest? 3. So this has a stop. So start it off the same way from the bracket y such that this is going to be everything below 3. So that would be y is less than or equal to 3. So anytime it only goes in one direction, you're only going to use one symbol, and that depends on the direction. The x-intercept on this kind of make up a decimal. I'm going to just make up a decimal. Excuse me. What's the y-intercept? Is this a function? All of your quadratics are functions. Do you have any questions, confusion on how we did that domain or range? Let's try the next one. What would the domain of this be? Negative infinity to positive infinity would be our interval notation. How would we write that in set building notation? Keeps going in both directions. You just say XER. You can say it doesn't want to. You could also just say it's all real numbers. What would the range be? But with y. So same thing, but with y. Y-E-R. Because it goes left and right forever and ever, and down and up forever and ever. The x-intercept of this, I'm just going to put it at 4, negative 4. And the y-intercept at 2. Is this a function? All linear functions are functions. I want you to try the one on the next page. And I'll give you a couple minutes to try that. Anyone think they have the domain of this one?
X less than or equal to 0.
You are close, except it would be everything greater than or equal to. This is everything above 0. So curly brackets, x such that x is greater than or equal to 0, and curly brackets. What about the range? It keeps going down and up. So curly brackets y such that y is an element of all of numbers. There's really only one x-intercept here. At 0, 0 is the same y-intercept. Is this a function? No. Does not pass the vertical line test. Look at the next couple of practice pages. Find any you want to see, do go over, have questions about. They're not numbered, so you could either number them and I figure out which one, or tell me the shape it makes. This is the domain and range of this one. And then if there are any others, I'll go back to that. So the circle, even though it doesn't look like it, has a starting and ending point. It doesn't go past this. It doesn't go past this. So I can say it's going to start there and end there. How would I write that? Isaiah, how would I start writing this? What's the first thing I need to write? Mm-hmm.
Y, then X.
Curly brackets, then X, then a line. And then where does this start? -1. What's the next part? What do I write after that? To be anyone. Or you can keep going.
It's less than or equal to X. That's less than or equal to 7.
And then curly brackets. How would I write the range of this? -1. I'm missing something. Oh, about y. Y is less than or equal to. Often when you get a circle, the numbers will be the same. Not always. Sometimes it depends on where the circle is placed. And the x-intercepts are a little off. for mine anyway, as are the y-intercepts. So I would put that at maybe 0.5 and 5.5. And then the y-intercepts again at 0.5. And 5.5. Is this a function? Yeah. Circles are not functions. Okay. For the one right next to it, the domain, is the x value moving? No. So anytime you see something that's a vertical or a horizontal line, that's just going to be it equals. So x such that x equals, what would that value be? 2. Now if you see a horizontal line, it would be the same thing, but for the range. In this case, what would the range be? And because this is a vertical line, it automatically fails the vertical line test, so it wouldn't count. Are there any others in the practice sections we want to see, do, go over, have questions about? I skipped the x and y intercepts, you guys can do those.
The first one on the last page.
This one on the last page. This one? So for this, think about where this keeps going. What would the domain be? All real numbers. ER, yes. What about the range? Same thing. In this case, this looks like there are multiple x-intercepts, but it's really just extended. So you could just put 0, 0. Is this a function? Are there any others we want to see, do, go over, have questions about? If not, you guys can have the rest of the time to practice. The Delta Math on this is due Friday. That will be one of the last Delta Maths. You guys can work on JLab, TestNav, 8-ball packet, practice from the notes, previous Delta Math, upcoming Delta Math. Be working on